Hey guys, so a classmate asked, how do you name organic compounds? Or more specifically, how do you name alkanes using IUPAC rules? To begin, let's first learn what these IUPAC rules are. IUPAC stands for the International Union of Pure and Applied Chemistry, which is an international federation of national adhering organizations that represents chemists in individual countries and which are best known for standardizing nomenclature in chemistry and in other fields of science as well. Alkanes are hydrocarbons, compounds that consist of hydrogen and carbon atoms made entirely of single bonds. The names of the first 10 straight-chain alkanes is shown here. You might be already familiar with the prefixes from 5 to 10, but watch out for 1 through 4, whose prefixes are unique to organic chemistry: meth, eth, prop, and bute. Note that naming of these straight-chain alkanes is based on the number of carbon atoms in the chain, with the number of hydrogen atoms equaling 2 times the number of carbon atoms plus 2. Now onto the actual naming rules. Let's say we are given the following organic compound to name, with some examples in line, angle, / skeletal form. The skeletal formula removes all hydrogens that will be represented in the Lewis structure. This leaves only the carbon skeletons with the attached functional groups. Each point on the skeleton formula represents a carbon. First, we have to find the longest chain of carbon atoms in the compound. This will refer to your base or parent name for the alkane. Next, any carbon groups not part of this base chain are called branches, substituents, or alkyl groups. Alkyl groups are substituents that contain only carbons and hydrogens and are named the same way as the parent carbon chain, but their names end in YL. Alkyl halides are alkanes bearing halogen substituents, and the following are the prefixes for such substituents: F equals fluoro, Br for bromo, Cl for chloro, and I for iodo. Third, number the carbon atoms in the chain. Note that which way we number the chains are going to vary depending on where the substituents are on our compound. Fourth, indicate the position of the branch on the main chain by prefixing its name with the carbon number to which it is attached. Be sure to write the branches / substituents in alphabetical order before the base / stem name, and ascending order if applicable. When the same type of branch / substituent occurs more than once, prefix the name with di, tri, tetra, depending on how many times it occurs, and be sure to separate 2 or more numbers with commas. Therefore, the final names of our 3 example compounds are 2,3-trimethylhexane, 4-ethyl-3-methylheptane, and 2-bromofluorochloropentane. Let's look at one final example where all of our rules come into play. With the following skeletal structure, we first find the longest chain in the compound, noted here in blue. Then we find the branches / substituents in our compound. We see we have 1 ethyl group and 2 methyl groups, for 3 total alkyl groups. Next, we number the carbons in our chain, with a total of 6 carbons allowing us to have a hexane base group. Rule number 4 states that we must indicate the position of our branches on this hexane base group, which if we number from left to right would be 2-methyl, 2-methyl, 4-ethyl. Remember that it is possible to number the opposite way as well. This means that we have 3-ethyl, 5-methyl, 5-methyl. 2,4,4 is less than 3,5,5, and so we use that numbering system instead. And finally, since we have the same type of substituents occurring more than once, we add a prefix to the name, changing the 2 methyls to dimethyl. Therefore, we can either name our compound as 2,2-dimethyl 4-ethylhexane or 4-ethyl 2,2-dimethylhexane. To determine which one we want to use, remember that we always order the substituents in alphabetical order first, and then ascending order if it applies. Since ethyl comes before methyl in the alphabet, then it's the first substituent we list, even though the prefix di comes first in the alphabet. Likewise, even though dimethyl's position of 2 is less than ethyl's position of 4, alphabetical order overrides that condition of ascending order, and so our compound's name is 4-ethyl 2,2-dimethylhexane. I hope this video helped you to learn more about naming alkenes using IUPAC nomenclature.